minutes each. Uh, so that helps us to solve some difficult or complicated problems. Just a minute, hold on, I'm getting a call. Okay, so but for this subject, we are having only a single session of 45 minutes per day or in one particular day. So this camps covering that entire problem in one class is very difficult if you guys are solving it along with me. So this one problem which you have kept incomplete in the previous class, so we'll complete in the same fashion. That is, you can do it along with me. But from next class, you can just sit back and relax, and I'll just keep on doing it, and you can watch. And if you have any doubts, you can ask. Once the entire session is or problem is over, then you can practice it at home later on. Is that fine?
Okay, sir.
Yes, sir. No problem. Excuse me, sir. So you are on mute.
Oh God, you should have told me before. I didn't check. Simply I went on explaining.
No, the cursor was not moving, so I thought you have purposely muted us.
Okay, okay. Uh, the screen is visible, right?
Yes, sir.
Okay, so this
Yes.
was the problem in the previous class, and as per that, we have completed the displacement diagram. Okay, and I have marked the points P1 to P12. Okay, and this semicircle naming was not done in the previous class. You can please name it from A to F. So wherever point A has intersected line number 1, I have marked it as P1. Wherever point B has intersected line number 2, I have marked it as P2, P3, and so on. Similarly for the return stroke. Now what I was telling is, if I consider this one point as point A here, and similarly the end point as point B, so you'll have to just imagine, if you hold point A in one hand, point B in another hand, and if you just bend it and make it as a circle, so whatever final shape you are going to get along with this displacement line, that will be your final cam profile. So that is what we are going to do it today. So if you just look at in the problem statement, we have the least radius of the cam as 30 mm. Okay, what does this mean? This means that I have the base circle, okay, whose radius is 30 mm. This is the least radius of the cam. So for this cam profile, there is some additional displacement given. Okay, that is what it means. So first I'll be drawing the base circle which is having a 30 mm radius. So you can do it along with me. So I'll draw a circle. The data is given as least radius of cam is 30 mm. So I've drawn the circle of a 60 mm diameter. Okay. I'll just draw one reference line which is vertically upwards. The reason why I'm drawing this reference line is I'm going to take this point as the starting point of the rotation of the cam. Yeah, that is why I'm going to start it here. You are having a absolutely free choice to take the starting point anywhere on the circle wherever you want. From there you can just go on measuring the angles. Okay, but the general convention or the general practice is that we take it in the vertical upward direction. Okay, so this is my starting point. Now this entire circle, whatever is there, I told you that it's nothing but the bending of this base line, rectangle line into a circle. So if you see the base rectangle line is 360 degrees and that circle is also 360 degrees. So in the next step, what I'll do is I'll just mark the rise stroke, dwell stroke and return stroke separately in the circle also. So first step is I'm going to draw the rise stroke which is of 120 degrees. Okay, so this is 120 degrees. Next step is I'll draw the dwell period which is of 80 degrees. I'll tell you, you'll come to know the reason why I'm just slightly extending these lines here. This is 80. Then I'll draw the return stroke which is again of 80 degrees. So I hope this part is clear. In the next step, the same thing what we have done in the displacement diagram, we need to do it here also. That is, we need to divide the rise stroke and the return stroke into equal number of parts. And here the equal number of parts should be same as that of the displacement diagram. So you cannot take there 6 and you can take here 8. That's not possible. So there we have taken 6 divisions. So here also I'll ensure that it is 6 divisions. Okay, please ensure that these are thin lines, what we are drawing. And see what I've done here. Those 6 divisions that I've made, I have given them a slight extension outside the base circle, because our cam profile will be slightly outside the base circle. I'll repeat the same steps for the return stroke as well. So let me know once you're done with this. So this will be my 0.01. This is 0.2. This is 0.3, 4, 5, 6, 7, 8, 9, 10. This is 11. This is 12. And this is 13. So on the base circle, 13 points is what I've marked.
Done, sir.
Just for reference, will be as it's a knife edge, I'll just be drawing a knife edge follower over here to indicate the starting point of the motion. Okay. Now I just, if you observe the displacement diagram here, the base circle, that is the bottom line of this rectangle, I've already converted into circle, and point 0 to 13 is what we have marked in the displacement diagram in the rectangle. The same 0 to 13 is marked on the cam profile also, that is on the circular base circle. The only thing that is remaining is now to bring in this P1 to P12 points. So the concept is very simple here. So I just need to measure the distance between point 1 and P1. Okay, you need to set the compass and measure the distance between point 1 and P1. The same distance arc has to be cut in the cam profile, that is between point 1, the same distance arc has to be cut over here. So it will come something like this. So wherever it cuts, this arc cuts the extension line, that becomes your P1. Okay. Similarly, I'll measure the distance between point 2 and P2. Either you measure it or you use a compass to measure that particular distance. So with that compass and with the center as point 2, I'll cut a line and that becomes my P2. Okay, we'll have to repeat the same process up to 0.6 here. So line 3 will cut over here, so that is P3. Line 4 may cut over here, so that becomes P4. Then line 5 will cut over here, say P5, and line 6 will cut over here, say P6. Then how about P7? What's the best way to get this P7? I can use the displacement diagram over here. Okay, hope it's visible. Yeah. From the displacement diagram, I can set the compass from point 7 to P7. Okay, this distance I can set the compass, and I can mark it on the cam profile to get P7. Okay, or else the best method is okay. Let me go to the displacement diagram. You can see that the displacement or the distance of P6 and P7 from the baseline is same. Okay, because both P6 and P7 are at the extreme top side of the rectangle. So the distance of the points P6 and P7 from the baseline is going to remain same. I'm going to use this concept, and in this cam profile what we can do is, with the center of the base circle, keeping this as the center and radius as up to P6, draw an arc until it cuts the line number 7. So that intersection will automatically become your P7. Even if you measure it, yes, it will be the same. But if you automatically draw this circle, that will definitely help you later on, because this is the dwell period. Please remember that this phase is dwell phase, and in this dwell phase, the radius is not changing. That's why I am drawing that arc with a constant radius between P6 and P7. I hope that's clear.
Yes, sir.
In the next step, now once I get this P7, so I'll have to locate P8 to P12 in the similar fashion. That is, use the compass between point 8 and P8, set the distance, and then in the cam profile you can mark that. So you'll be getting somewhere arc over here, that is P8. Similarly for P9, this will be for P10, P11, and lastly this is P12. If you see P13, we have not marked that in the displacement diagram. P13 will exactly lie on the baseline. That means it will lie on the base circle in the cam profile diagram. So I'll just locate that P13 in the cam profile diagram over here. So it will overlap with this point, that is P13. Okay. So once you get all your points, that is from P1 to P12, the next step is to join them by a smooth curve. Okay, ensure that while you're ending at the P13, there should not be a jerk over there for the follower motion. It should have a smooth ending over there.
Sir, you are on mute again.
No, this time I intentionally muted. I'll wait for you guys to finish up.
Yes, sir. So we are done with marking points.
Yes, sir.
Okay, so the next step, just join them by a smooth curve. So I might not get a good diagram here using these tools. Something like this. Okay. I'm not drawing the perfect diagram here. This is the part I was talking about. At point P13, it should end with the smooth curve there. Okay, then we'll also darken the remaining curve. Of course, this you can do it using the compass here because it's the perfect 12 face. So from far, this is what your cam profile should look like. That is whatever I've drawn in the green color, that is the one which should be highlighted.
Done, sir.
Now, very quickly, within next 5 minutes, we can also finish up one more problem here by slightly making a modification in existing problem. Okay, so let me change the problem here. See, I'll just add one more sentence at the end of this problem. The rest all data is going to remain same. I'll just add one additional sentence on here. Say that the axis of the follower is offset by say 12 mm towards right. Okay, so this is the new sentence that we have added here. So you can note down this starts from here. It says that the axis of the follower is offset by 12 mm towards the right. Rest all data is going to remain same. Okay. So with this, our displacement diagram is not going to change. The displacement diagram is going to remain same as it is because here we are not considering the axis of the follower. Okay, it's only about the rise stroke. It is still 120 degrees only. It is still SHM, so the same points will come. We are still having dwell of 80 degrees and we are having return of 80 degrees with UV. So again, the same point. So displacement diagram will be intact for this second problem also. Only thing is there will be change in the cam profile. So what I'll do is I'll delete these lines. In fact, let us delete all lines, please. So we'll draw the base circle whose radius is 30 mm. Okay, in the earlier case, you have seen that the follower axis was exactly in line with the cam axis. This is what I'm talking about. This is the follower axis over here. This is in line with the cam axis. Now they say that this follower axis has to move 12 mm towards the right side. So whenever such situation comes, we'll be drawing one additional circle of radius 12 mm or diameter 24 mm. Okay, so you can just listen to me and later on you can do it. since I am saying that the follower is offset by 12 mm towards the right, I have drawn a circle of 12 mm radius, and then I will, okay, just a minute. I'll draw a line in this fashion. What I've done is I am taking the initial position for the motion, not exactly vertically at the center of the base circle, but this line is going to be tangent to that 24 mm diameter circle, smaller circle, or 12 mm radius circle. This will be acting as my starting point of the motion. Okay. Now I'll draw one more line from this point to the center, and this line will represent the angular initial position. That means my right stroke should be starting from this line. I should measure 120 degrees starting from this line in anti-clockwise direction. So I'll show you. Let me draw that. Sorry. This is 120 degrees. Okay. And once again, we need to divide them into 6 equal parts. But here is the tricky part here. Now, if I divide, let me show it. If we do it like the earlier case, that is, if I take this line and select the center over here, okay. If at all I do it like this, then it will be wrong. Why it is wrong? Can anyone tell me?
Just like previous problem, so as you said that we can select initial position anywhere, so it will be same as the previous problem.
Yeah, but I said now this 6 divisions what I have done, these I'm telling that these are wrong. I want to know what is wrong in this step.
So those are not tangent to the inner circle.
Exactly. Since my first line is tangent to that smaller circle, all the remaining lines also should be tangent to the inner circle or the smaller circle. So I will draw that here. Of course, the division should be made on the base circle. Okay, with these divisions, I'll be drawing the tangent line in this fashion. Then I can delete this line. Similarly, I'll take the second division and I'll draw the tangent line. We'll delete this. Okay, like this. Of course, I'll have to extend them. So to extend this, I'll just use this option here. Okay, so this is your right stroke. Of course, I should not have deleted this last line over here, because this line which I have just now highlighted, this becomes our starting point of the dual stroke. Okay, so this is the difference. Now again, of course, you will have to use the same method of measuring this distance 1 to P1, 2 to P2, and so on, and mark it over here. Is it clear, this problem?
Yes, sir.
Yes, sir.
The remaining all will remain same.
Yeah, but you'll have to be a little bit careful while doing the return stroke tangent lines. You can see now the tangent lines are joining. See, the tangent lines are moving in the anti-clockwise direction. In the same fashion, it has to go in for the return stroke also. I'll just show you an example. What everyone usually the mistake they make. Just let me draw it here. Here, let me assume that. Okay, sorry. So let me assume that this is our dual stroke here, and then you mark the return stroke somewhere here, and then I'll make 6 divisions here like this. Okay, now I'll have to join it to the tangent. So make sure that this is joined on this side of the circle in this fashion, because some of the students have joined it on the right side of the circle, but it has to be joined on the left side of the circle. I hope this is clear.
Yes, sir.
So this is how the return stroke will look like. Rest all marking from the displacement diagram onto this will remain same as it is. Okay, so in the next class we'll take up one problem on using the roller follower, and the type of motion where we'll change it. Instead of this SHM and we will take cycloidal as well as uniform acceleration both. Okay.
Okay, sir.
Yeah. And I'll be giving your IO marks by today evening or at the max tomorrow morning.
Yes, sir.
Okay. Thank you.
Thank you, sir.
Thank you, sir.